there's a couple of people I've known before and some people I didn't. And I've heard about you, I have to say, before
Really?
you wrote me. And one of the purposes of this event is that we finally meet. So
Yes.
I'm really not competent to say anything about you, and I'm really looking forward to hear something about you from you. So if you can, please introduce yourself and
Okay,
show us
I
what
will.
you're doing. We are very excited.
Okay, great. So first of all, let's start this. First of all, thank you very much, Jan, for the possibility to speak here in front of you today. There are going to be great speakers, and it's really an honor for me, and furthermore, a great pleasure to be part of this conference. I have studied architecture on Technical University and FH Erfurt in Germany. I'm a lecturer on Technical University since 2013. I'm doing a lot of work also as a freelancing architect, and I'm doing a PhD supervised by Manfred Berthold and Margit Köhler on Technical University. And this is what I'm going to show you today. It is about a self-organizing kinematic structure, and it is starting out with some abstract studies I've done in digital studies. This is really just messing around with different tools, mostly Blender 3D. I guess you know it. It's about a lot about Python scripting and about what could you get out of algorithms like subdivision and stuff like this. This is another picture. I'm interested in this complexity of these shapes. Furthermore, someone has already introduced Boyd systems, swarm behavior, stuff like that. And I always thought to myself, isn't there a possibility to bring this more to architecture? So for me, this is architecture, but to bring it more to a architecture that is working as a building. And this is a PhD going to be about. It is based on a really simple idea, the variable geometry truss by Mueller, invented in the 90s to develop space cranes in the use of outer space. And the idea is quite simple. You have simple elements, single trusses of a structure, and you replace it with linear actuators. And what you get is somehow a variable mesh. And this is an idea I was really fascinated of. This idea from Mueller, you have this variable mesh, and as you know, you can split merely every shape in computer graphics up to merely the same size of triangles, and therefore you can animate it and create a wide range of different shapes out of this idea. So a lot of the study is about the analysis of, you might already know, having a triangle versus quads versus n-gons. Of course, the triangle has one big disadvantage. It is producing a really small amount of area with a high need of elements. But it has two really big advantages. First of all, it is statically defined. And the third big advantage, it is always a planar surface, which can be a big advantage in different situations. The quad is somehow in between, and the n-gon has a lot of efficiency in the areas. So you can create a huge amount of areas with the same element size. So the study is always same element size. As you can see, it's much bigger. But two big disadvantages: it is not statically defined when you think of variable joints. And the third disadvantage, there is a high amount of displanarity. But I have chosen afterwards this shape, and I will show you how it works. So first of all, continuing with, imagine this variable geometry truss connected to a mesh. As you can imagine, when you only have fixed variable joints, you will have the problem that every line which is going through is somehow not stable. So actually a plate, a flat surface is completely useless when you're thinking of just variable joints. What you would need is you would have to deform it at least in one direction to get a stable shape. Imagine a sheet of paper. When you bend it, it is stable in one direction, and if you double curve it is stable in both. Other possibility, of course, would be to double it up, having two layers, and a third possibility, doubling it up and having connections in between them. So this is one small glimpse into the programming beyond. This is a Python script on the left side, which is going to set up the kinematics for this mesh you can see. When transforming this mesh, all these linear actuators will follow, and therefore it will be possible to clone them to a model in the physical world. You can use every common tools you would use for mesh deformation, proportional editing, all these simulation models, etc. Another big part of the study was how would you cover such structure. You could think of another mathematician like Mueller. Ron Resch has invented this pattern. Every one of you knows it is a method of creating a double curved surface without any bending of the material, only with folding. Here you can see it applied to the shape. You can think of expanding material. So this is all about the question, how could you how are you able to create a surface which is able to make this change of scale? Layering is another idea. Predefining it in 3 directions to make it able to bend. Pneus, for example. Fibers is another idea. How could it finally react on movements? So here you can see one simple example, a moving person. You have a sensoring system which is able to recognize this movement and displace the surface. So this is dynamic painting. Here you could see it with particles this is just should simulate just a movement of more people than just one. A simple Boyd system which is going to displace the surface. Here you can see it in simple sections and floor plans. And apply it to this idea of this Resch pattern before. There has been a big research in these nodes. How could you create such flexible nodes in every direction, especially with the triangle. And until this point, this was a big point in the research, because what you have seen until now was completely top-down. It is a surface you create and you're deforming it somehow as a designer, and you're bringing it to the physical world. It is exactly like we're doing architecture right now, only in a kinematic way. And wouldn't it be better, and I guess this is the sense of this conference also, having something which is working bottom up, organizing itself. And I started out with a Boyd system, like the colleague before. This has been shown from Greg Reynolds on SIGGRAPH, merely 20 years ago, 1980, sorry, don't mind. And it is about a possibility how could you simulate birds in movies, in computer games, etc. And the clue about this concept is that you have simple agents, and every agent, so every circle in this case, has an own intelligence, which is allowing him to move closer to others, copy their angle, their velocity, etc., and therefore creating a swarm, like you can see here. Every one of these circles has the possibility to recognize their neighbors and to change their behavior according to their neighbors. And there is no overall controlling system. It's only the intelligence of each single member. And as you can see, they are already creating surfaces. So in my simulation, it is slightly adapted. It is a little bit an adapted code with more conditionals in order to create really a circle packing, but it is, like before, a Boyd system, only with the advantage of really creating a smoothless surface. It's not working completely, so you can see some of them are eaten up. This is this working? Yes. How I would like to translate it into architecture. So imagine this as singing. Oh, maybe yeah, no, it's okay. These are these agents represented as circles. They are working like somehow hexabots. I will show you this in the small prototype right now. Imagine this like a hexabot with two pairs of feet, existing of 6 feet, two pairs of 3, and there is an inner circle and an outer circle, and with these two pairs it is able to walk. Somehow to walk, it is able to connect to others, moving together. And finally, how they could manage to create space. This is one of the main topics I'm going to go into right now. So the idea is you have an agent which is able to connect to others and create a seamless surface. So in the picture before, you were able to read all these single agents. Here you really have the impression it is seamless surface. Just one short simulation on the deflating and expanding of the pneus. But I guess this video is not working. Do I have to click? Sorry. Here you clearly can read these single agents. Here it is really getting to a seamless surface. So coming to the idea of load deflection, the first step was, and I guess you have to do it to prove somehow an overall structural performance of the system. The first step was taking sections and asking the question where would be the worst case of the whole structure. And of course, you can see that these diagonals, these are the worst cases you could have. And of course you can think of just calculating these worst cases, and you can came up with somehow a logic that the modules are not expanding if there are much more. But this is also a top-down principle. So the question is, how could you bring this to this self-organization concept of the whole project, and how could you think of a system which is able to create an overall quality like load deflection with elements that are they do only have their own intelligence. And one of the simplest examples for this is a chain. You do know this from Gaudi. He reinvented it somehow from the Middle Ages. Frei Otto Isler brought this idea literally to the next dimension. I want to discuss it in a slightly different way, because the chain is somehow one of the simplest types of self-organization you could imagine. Every single element is dragged down by gravity, so somehow you could define it as a goal. You are dragged down in a set direction, and furthermore it is has the rule to be in the link strange of its neighbors. So if it is closer, he is going to move away. If it is far away, it is going to move closer. And this is somehow creating a self-organizing system. If you would drag one of these points out of position, the whole system after time is going to rearrange. And by the way, setting up an ideal solution for this case of hanging down. So the idea of the guys mentioned before is of course to turn this around. And you get a structure which only has normal pressure, so no tension, etc. But if you would now take one single element and push it out of its position, the whole structure will collapse. So somehow the chain is really a system which is quite peaceful, if you want to imagine it like this, because every link is putting its load to its closest neighbors, and they are working somehow together to create this overall ideal shape. If you're doing this as a catenary arc, it is somehow the whole piece is lost, because if someone is not in this normal strange position, all others are pushing down on this one weirdo out of scale, right? So the idea would be to setting up a system which would really turn this around. So imagine all these joints you have are able to recognize the force they get with DMS stripes and doing exactly the opposite way. This is the idea of how you could think of a self-organizing structure, which is also doing self-organizing load deflection based on the intelligence of own agents. You're just turning around the forces you will get on joints. So this is the main idea of this project in order to get to come up with self-organizing architecture like shown on this picture before. So just to show you this as an example on the prototype. So first of all, the movement. I'm not sure if you can see it from the back, but maybe afterwards there is a possibility to watch it from closer. So they are moving in a way that one feet is pushing to the side and pushing the other two forward. So quite simple idea. And Another example of how every truss is able to change its angle in order to only get normal pressure from their neighbors. So this is the idea of how you could do this organization with, not with triangulars, not with quads, but with n-gons and with the intelligence of the own agents only. Okay, so at this point I want to thank Manfred Berthold and Margit Köhler for supervising this PhD. I want to thank Jan Pernicki again for the invitation and the possibility to speak here, and I want to thank you, the audience, for your attention. Thank you very much.
Probably finally ask something too.
Yes.
Well, not only just bringing the food. I wasn't able to follow the until the very end, but I saw most of your presentation and it's
Yes.
impressive. I would be interested, just for my better understanding,
Yes.
when you are using elements and you're actually having physical elements that have their own intelligence, and you're trying
Yes.
to use a bottom-up system that is self-assembling or actually doing something on its own, what is your main intention while doing that? So what is the thing
Yes.
that you, what is the departure point from which you actually are using these things?
Yes, that's a good question. Big advantage of those self-organizing and agent-based systems is, like, you know, these projects from MIT, reconfigurable robot systems, etc. The big advantage is that if you have one damaged module, it is just replaced from another, completely autonomously. So this system has somehow a really high ability to repair itself. So if one module is damaged, it could be just taken away. Another advantage is that you're always gaining the maximum of, for example, space you could create. Imagine there is a higher load on the modules, they would not just get so big. If there is less load, for example, there is no snow, there is no rain, etc., they are getting bigger. So this would be another advantage that you can create on, that you can react on different environmental changes. Also wind. So imagine this chain. If you have wind in one direction, it would be able to react on this. So these are arguments for agent-based structures.
Christoph, I have a basic question. All these things are autonomous, right? They're walking
Yes.
robots, pretty much. Where do they take energy from? How do you power them? Like,
Accus. So that's a good question. So there is an idea of powering with with solar, but of course you always have the problem that it is always based on the weather. So these are these two ideas: powering with storage. So you have some accus and filling up these pneus with photovoltaic.
okay. So you simply charge them every now and then? Like,
No, that won't be the idea. So there is, of course, a small research on how actually would you drive them. You have the ability of pneu cylinders, you have hydraulic cylinders, and the idea of electrical, how do you call it? Spindelmotor, also electrical linear actuators. They all have advantages and disadvantages. Pneus, for example, do have a little bit the disadvantage that they cannot bear as much load like hydraulic cylinders, etc. But you would need a compressor for every model, so the idea of electricity is somehow this what I'm sticking to until now, because you can create a lot of force with screwing a truss, and furthermore it has the big advantage that if you do not have energy, electric actuator is still able to vary a force. If you are not able to run a hydraulic cylinder, he's going to, yes, the structure is going to collapse.
Can I ask,
Yeah.
this system of movement, it actually could quite well work on flat surfaces, but for example, this project that is here, this example shows that they are already creating a 3D structure in the air and so on. But this movement, I guess, would not be sufficient to actually create this kind of structure. And basically, I cannot imagine how this robot would climb to the air and create this kind of shell structure.
Yes.
It's not sufficient, right? This kind of
Yeah, that's true. Yeah, it is working in somehow slightly variation of slope, of course. But I guess if you're talking about this problem, the main problem would that you are only able to create single stores. So you are only creating pavilion near structures in urban context, for example, where you would need to change architecture and where you would need to react on different movements. But it's true, you won't be able to do it in an angle which is too slope.
But maybe they can climb on each other.
Yeah, but then it's the question, how would they connect to it? So it was really a big question about me, how could I get to a multi-layering system? So maybe they could, yes. So right now a big advantage would be that these joints are, because one question is how do they connect to each other. One big advantage of this catenary is, of these catenary structures are that you only have pressure. And of course you can have 3 single beams going together and working just with pressure. If you have somewhere dragging force, you of course running into more problems. You have a question, I think so.
Always. It's coupled with some of what you were answering right here. I mean, in one of your earlier slide, well, the first slide too. The first slides, you know, to switch back. You've gotten to the point where you're actually creating a space inside. It creates this kind of blob kind of
Yes.
bubble structure. But yeah, I would be curious at how we start dealing with how this kind of self-organizes itself into, exactly this, into maybe a primitive, even at this lowest level, say a cube or even a pyramid.
Yes.
And then at the second level, a jack or a ziggurat or something like this, it's a little more
Yes.
advanced. Would it merely organize itself as a surface condition like it's doing here, or would it have actually an organization throughout the center of the void of the primitive when you're dealing
Yeah.
with natures?
So you would mean, would I be able to
Make a wall.
program in the way that they would create, for example, a cube? Yeah, that's this won't work in a lot of conditions. It would work if you have this example here with. I go back to one previous slide. If you would only have one, maybe let's start it out differently. If you have a structure like this, which is doubled and which is diagonally connected to, then you would be able to create merely every shape out of this. Like a sheet of paper, you could bend in every direction. Having only this one layer would mean that you wouldn't be able to create a flat surface, right? Because the problem is, if you imagine these lines, they are all variable joints, yes? So all of them would just fold, right? So in this case, having just one layer with these models, you wouldn't be able to create somehow a wall and a roof on it. It only would work if you double bend it in both directions. Sorry, running out of time. So this would be a disadvantage, but there is somehow, going back to...
First ones, how would you create your very first images? Like, I think that's where you want to go, right? The very first studies you did with the white and the kind of...
Ah, you mean this one?
This is where you want to go with this structure, I'm assuming.
Not completely. So it was. These are just really freely studies. This is really messing around with computer graphics, but they are somehow producing this idea because this is a top-down. What you can see here. This is a surface which is subdivided regarding different weights and creating a typology which is not based on triangles, not on quads, but on complex n-gons. And I guess the first step was into this image, into the self-organization idea. And furthermore, it is much more about the qualities it produces, like this gradient between this noisy texture getting to somehow this porous texture. You could not decide, is it ornament, is it material property or whatever. So somehow this Hansmeier topic, this was the ideas where I started out. But I guess what came up in this last image is a system which you could not decide what is design process, what is production process, what is this intention. It is. So my fascination would be how far can you go with this intelligence of the models, of their own modules. Of course, I could say there is a top-down rule for bringing...
When you make a bench, you basically put a top-down rule on a bottom-up system. Say, oh, now it's a bench, we have to stop at this size.
Yes, that's true, that's true.
And so, I see the work. You could, I mean, it's very, by the way, it's very well articulated and it's very interesting.
Thank you very much.
And it has very fabric type ability to it that I could see it further going into, more figural shapes and having intention, not just a bench, but a chair or even a column.
Yes.
And it's kind of organizing system. It's fascinating.
But the quality of flocking or the small image is actually it has holes.
What do you mean?
It has holes. It has a certain porosity.
Yes.
So when you're now taking account like your chain model or the entire system, so if I would not take out so many holes, just it means like your triangle model should work in like over perceiving your elements as parts, like over the parts of this element. Or like creating this triangle structure over overall assembly, or like somehow you should work with forces. So then you anyhow can get rid of the triangle. What you say like in the beginning, that the triangle is actually does not have like really nice quality.
Yeah. So, that's true. So this is an image of there has been a variation of different modules, because if you're this one is with 27 linear actuators each module, which is an extremely high amount, but you would have the possibility to make also use them with dragging forces. You could use them in more complex setups of creating, for example, situations to sit on, etc. But right now it is going more in a direction like the one before, which is only based on 6 elements, because in this case you would have extremely loose of weight, etc., but you're somehow losing possibilities. And if you look at this one here, you only have here are 9, and in the final one it's only 6 motors. So it's getting more and more somehow efficient, And right now I'm trying to get these qualities of the higher actuated modules back into these small modules. But right now it's no triangle, it's this one is an n-gon with 6 edges which is created. Do you know what I mean? It is.
Yeah, probably. I mean, can you make like there's always a complaint about Christoph Mueller that he was an architect because he couldn't make a door into the domes. So I mean, like really very simple problem.
Yes.
How may actually make a note or take something from the structure but still keep
Yes.
all the possibilities.
Yes.
I said that we are going to be merciless when it comes to the time. You're out of your time.
Yes.
The lecture was amazing though. We still have the whole Sunday morning to discuss things. And this is also an intention that this is just a teaser and the real discussions are going to happen really on Sunday morning. So thank you very much.